Okay, 16.1, electric current. Electric current is caused by moving electric charge. We talked about this before, that it's the electrons that are actually, how about pen, going down the wire and traveling through the circuit, kind of like the roller coaster. You start at the beginning and you go around and you go back to the start again. Okay. So it all goes back to the electrons of being used to make the electric current. Wires in electric circuits are similar in some ways to pipes and hoses that carry water. Think about how the water comes into your house. It comes to your sink, it comes to your toilet, it comes to your kitchen sink, it goes to your shower. But it doesn't go out the same way it came in. It has to go out the drain. Okay? That would be kind of gross, cross-contamination. So it's one-way paths. So you have a water supply coming in and a water return of the dirty water going out. Goes and gets cleaned, comes back. Same thing with your electric current. You have the positive, the current coming in, and the current that goes out, the return current. That is why when you look at your outlets, there's two prongs on your outlets and on your electrical appliances.
Is that why one prong is like thicker and longer?
Exactly. Same thing with the LED light. Remember your LED light had the short one and the long one? You have a positive lead and a negative lead, and that's the same thing with your, you always have that one that's kind of like that wider shape, and then the one that's the square. Yeah. And that's why, because if you reverse it, like when you put your light bulb in the squishy circuits the other way, it didn't work. Same thing. It's not going to work if you plug it in the wrong way. But why do some plugs have this third hole on them? What is that third prong's purpose?
Doesn't it make it the voltage higher?
Doesn't make the voltage higher.
Does it supply more electric? No, it doesn't.
What does it do?
It grounds it out. It's the ground. Means that when you go to touch it, that if there's an electric current that's going through it, it's going to ground out so you won't get shocked. So if you do not have that grounding one, it's more dangerous because the electricity can travel different places because electricity travels the path of least resistance.
For my laptop charger or whatever, there's like there's the third one, and it sparks more than the ones that don't have the third one.
Because that spark is traveling down that third prong, right?
Sure.
Where is it sparking at?
I don't know, it just sparks.
What sparks?
When I go to plug it in, like as soon as I touch it, it just sparks. Like.
Yes, so it's grounding out those extra electrical charges that are left on that. If it grounds out there versus to you. Because you are a path of least resistance. Okay. So we look at circuit diagrams, and you did this. We saw these in your homework. You have your switches, which are resembled by the door-looking symbol. And then we have the light bulb, and then the positive and negative, which represent the battery. Circuit diagram. Are we going to do what? Are we going to do it like a yes, on Friday? Okay. So when you look at the different symbols, you have the wire, the battery, the bulb, and a resistor, and a switch. So you're familiar with most of these? And it's easier to use the symbols versus drawing a real battery kind of thing. So it's kind of shorthand of drawing electric circuits. So you have your pictures on your paper that you're going to label next to them what they are. There's a line in between them. You can write it on that line, but you have to write really small, or you can write it to the right of the pictures as well.
What is a resistor?
We're getting ahead of yourself. We will talk about what resistors are. Correct. Resistor. Switch. Resistors is an electrical device that uses the energy carried by the electric current in a specific way. Any electrical device that uses energy can be shown with a resistor symbol. So it's using the energy. I had some people actually with the squishy circuits try to use themselves as the conductor to hold on to the LED and hold on to the battery pack to get the light bulb to work. It didn't work. Why? We are so large compared to the power that was supplied that there wasn't enough energy to travel through us, because when the energy comes into us, there's not one path that it can travel. It can go all over your body. So the larger it is, the more resisting that there is in the circuit. Okay. Here are just samples of the circuit diagrams and using the symbols, which you guys are familiar with because you saw this on your homework. And open and closed circuits. You're now familiar with this because of your homework. So we have the closed circuit, which is a complete or unbroken path. And when you flip the switch to the off position, it creates an open circuit, making a break in the wire. Think about when you turn the light switch on, what are you actually doing?
You're connecting the circuit.
You're connecting it, making it closed. So when you turn it off, you are opening the circuit to prevent the flow of electrons of making the lights work. So the key thing that you have to understand is the misconception of thinking about this as a door. It's not a doorway as if it's open you can go through. It's about a path that you can take. So it's talking about going back and forth. So if this is not down, the electrons can't cross because it has nothing to cross through. Because electrons have to have something to pass through. They can't pass through an open gap space without a conductor there. Does that make sense? So down here, the switch is closed, so you have contact of the metal, and metal is a good conductor, so they pass through and make a closed circuit. So closed meaning that there's no breaks in this circular circuit. Does that make sense? So switches are used, and flipping the switch to the off position creates an open circuit like we said. So again, you see this in everything that you turn on or off. Okay. Does that make sense? So open closed circuits.